Welcome to today's lecture on mathematical operations using significant digits. I'm Drew Collop. In this lecture, we're going to take all the knowledge we have in terms of BEDMAS and significant digits and combine them together. In the laboratory, we make measurements. We then use those measurements to make calculations. The last digit in a measurement is oftentimes not exact. There's some uncertainty associated with it. When you use this in your calculation, it can make your calculation also inexact. As a result, we must round appropriately using significant digits. Let's explore the rules associated with multiplication and division, and then we'll look at addition and subtraction. For multiplication or division, we keep as many digits as the factor with the fewest significant figures. Figures are the actual number of digits in each number. So we count up the number of figures in each of the numbers in the calculation, and we round off to the fewest number of significant figures. Let's examine that now. So here we have 12.4 times 5.1. So plug that in your calculator, and we get 63.24. So remember, we're not rounding off until the final answer. But now we're at the final answer. So let's go back. 12.4 has 3 significant figures, and 5.1 has 2 significant figures. Which one is less? 3 significant figures or 2 significant figures? Well, 2 is less. Therefore, we're rounding this digit off to 2 significant digits. We look to the one number to the right. It is a 2. It's below 5. So this rounds off to 63. Final answer. Now notice here, I didn't say equals. I said approximately equal to, indicating I have rounded this number off. So again, with multiplication or division, we're going with the fewest number of significant figures. Now we have division. We do 12 divided by 5.12. We get 2.34375. I'm writing down all the digits from my calculator. I'm going to go back. I have 2 significant figures. I have 3 significant figures. So again, we have 2 is our lowest number of significant figures. We're going to round this off to 2 digits now. So this rounds off to 2.3. Next up, we have units in here. Let's do the multiplication together. Multiply those together. 12.4 times 5.127. Write down all the digits from your calculator. 63.5748. Our units now, we have centimeters times centimeters. There's actually an exponent on this. It is an exponent of 1. Let's think back to our exponent laws. If I have the same base, I'm multiplying it. What do? I add those exponents. So this becomes centimeters 1 plus 1, giving me centimeters squared. So that's where centimeters squared comes from. We can use our exponent laws on our units. Now let's round off to the proper number of digits. Here we have 3 significant figures. Here we have 4 significant figures. 3 is less than 4, so we're going to round off to 3 significant figures. That number is greater than 5, so this rounds off to 63.6 centimeters squared. Remember, if there's units in there, you must include them. So as a reminder, when you're multiplying or dividing measured values, you're going to have extra values in your calculator. Those values are meaningless digits. We remove them at the end when we use our rules for rounding significant digits. However, we wait until the end. We wait for the entire calculation to be completed and then round off to the final answer. So as a reminder, do not round off until the final answer. Do all your calculations for every single step and keep every single digit you can in your calculator until the very final answer. And then at the final answer, only then do you round off. I'd like you to try these practice problems now. Pause your video, give them a try. Do the operation and round off to the correct number of significant digits. Let's take them up. 5.92 times 3.0, 17.76. Here we have 3 significant figures. Here we have 2 significant figures. So we're going to round it off to the lowest number, 2 significant figures. Look to the one number to the right. This rounds off to 18. Next up, in this case, we do 8.2 divided by 3.194. We put down all the digits from our calculator. We're not rounding off. Now we're going to round off. Let's look at this. We have 2 significant figures. We have 4 significant figures. This is rounded off to 2 significant figures. This becomes 2.6. Look at this. We have the numbers in scientific notation. Same rules apply, though. Let's combine them. We're multiplying them, so we can do 6.10 times 2.08 multiplied by 10 to the 3 times 10 to the minus 4. Work that out now. 12.688 times 10. Combine these now. We're multiplying 2 exponents with the same base, so we add the exponents. 3 plus minus 4 is going to be minus 1. This number is not in proper scientific notation. Let's convert it over to proper scientific notation. We can move the decimal place over 1. This gives me 1.2688 times 10. We made 12 into 1.2. We made a big number smaller. To offset that, we have to make sure it's a positive exponent, and we move 1 decimal place. Multiply it by 10 to the minus 1. Combine those together now. 1.2688 times 10. Combine those. 1 plus minus 1 is 0. 10 to the 0 is just 1. 1.2688. Now we're at the final answer. Now we round. Let's examine here. We have 3 significant figures. We have 3 significant figures. How many significant figures in these values here? There's an infinite. These are defined values. 10 to the 3, 10 to the minus 4. These are infinite values. So there is an infinite number of significant digits in these values here because they are exact. We're going to round off to the fewest number of significant figures. What's less, 3 or infinity? Of course, it's going to be 3. This gives me 1.27. Final answer. So when we're multiplying or dividing numbers using significant digits, we look at the fewest number of significant figures. That's the actual number of digits in each number. It's different now for adding and subtracting. When we are doing addition and subtraction with measured numbers, we need to round off. We keep as many decimal places as the number with the fewest number of decimal places. So multiplying or dividing, we go with significant figures. With adding and subtracting, we go with significant decimal places. If we have a whole number, we look to the number with the highest place value. I'll explain that in example 6. So let's look at some of these. Here we have 43.1 plus 52. We add those numbers together. We get 95.1. Now let's examine the lowest decimal place. Here there's 1 decimal place. This is the 10th. And here there are no decimal places. This is the ones column. If we look at the 2, we look at the 10th column, we look at the ones column. We find the one that has the fewest number of decimal places. Well, that's going to be the ones column. So we're going to round off to the ones column. Look at the number beside it. This rounds off to 95. Let's try the next one. 43.1 plus 52.3. So it's the same sort of question, but now I have a 0.3 in there. Let's add those together. 95.4. You can see I have 1 decimal place here and I have 1 decimal place here. This is the 10th and the 10th place value. So I'm rounding off to 1 decimal place, or I'm rounding off to the nearest 10th. In this case here, 95.4. I'm still going to write the approximation symbol to indicate that I have applied the rounding rules here. Let's try a few more. We add these 2 numbers up, we get 9772. Let's look for rounding. Here, this is the ones column. Here, these zeros are not significant. They are placeholders. So the first significant digit is the 4. This is in the hundreds column. So I round to the nearest 100. This gives me 9,800. Notice these almost look the same, except this is bumped up by 10. Now let's examine. Here this is ones, here this is the tens. So I'm rounding off to the nearest tens. Once again, this 0 is not significant. It is just a placeholder to tell us the 1 is in the tens column. Finally now, here we have units. We add these numbers together. Now, when you're adding or subtracting values, they must have the same units. That's very important. If they don't have the same units, you can't add or subtract them. We'll talk about this later on. But you can see they're both in terms of centimeters, so we can add or subtract them. We combine these, 9762. Now we look at significant digits. This is to the nearest ones column, and this is to the nearest tens column. So we have to round off to the nearest tens. 9760. Don't forget units, centimeters. Should probably put that in here. So once again, if there are units, please include them in your calculation. I only did addition here, subtraction, the rules are exactly the same. So why don't you give these a try right now. In A here, one thing to check, you can see they all have the same units, so we can add these directly. We're adding them all up. We add them all up in our calculator. No need to do them individually. This all adds up to 10.2352 grams. Now let's look at significant digits. First one here has 4 decimal places, 2 decimal places, 3 decimal places, 3 decimal places. So 2 is the lowest number, so we're going to round off to 2 decimal places. This becomes 10.24 grams. Next up, 24.2 mils minus 0.67 mils. Again, you can see same unit, so therefore I can add or subtract them. In this case, subtracting them. Subtract them now, I get 23.53 milliliters. This has 1 decimal place, this has 2. Which one has fewer? Well, 1 is fewer. I'm going to round this off to 1 decimal place. This becomes 23.5 milliliters. Let's go back and examine this for a second. So this one was to 2 decimal places, 0.67. This one, I only measured it to 1 decimal place. So the question is, what's this next decimal place? What is it? Is it 0? Is it 1? It could be anything. As a result, this value here is less precise than this value. As a result, when we do a calculation involving that value, we can't report it to 2 decimal places because we don't know what that second decimal place was on the 24.2. It could have been anything. And that's the reason why you must round to the fewest number of decimal places, or the highest place value if there are no decimal places. In scientific notation, let's review this. We're adding 2 numbers in scientific notation, so they have to have exactly the same exponent on the base of 10. Also notice we can add these because they're both in terms of exactly the same units. Let's put them both in terms of 10 to the 1. So this one here, if I want to make this 10 to the 1 centimeters, I had to take this and bring this down 2 decimal places. That means I got to raise this up 2 decimal places. 1, 2. This gives me 532.0 times 10 to the 1 centimeters plus 4.212 times 10 to the 1 centimeters. Now you can see we have them both in terms of 10 to the exponent 1. Now we can combine them. When we add those together, we get 536.212 times 10 to the 1 centimeters. Remember, once they are the same, that remains the same. We just added these 2 up to get this value, and then we took this value and we just didn't change it. You can see this number, 536, is much larger than 10. This number is not in proper scientific notation, so we should convert this over. However, when adding or subtracting, I would advise you to round it first and then convert it to proper scientific notation. Let me show you why. So here, we look at the number of decimal places. This one has 1 decimal place. We look at the number of decimal places here. This one has 3 decimal places. We can compare them because now they're in terms of 10 to the 1. You cannot compare these values here because one's in terms of 10 to the 3 and one's in terms of 10 to the 1. So yes, you could do this in your calculator without having to convert, but then you won't know the number of decimal places. So you must do this not only to do it properly, but also to make sure you know the correct number of decimal places. So here, we're going to round off to 1 decimal place right here. So this rounds off to 536.2 times 10 to the 1 centimeters. This is not in proper scientific notation. Move this over to 5.362 times 10. We moved it over 2, and we made a big number smaller. So to offset that, I have to make sure that's a positive exponent, times 10 to the 1. And then finally here, 5.362 times 10. We're multiplying 2 values with the same base, so we add them, 10 to the 3 centimeters. Final answer. Now notice, this 0 here is not just a placeholder. Why? This is in scientific notation. There are no placeholders in scientific notation. If it's written, it's significant. If it's not significant, you don't write the 0 in. To recap, when you're multiplying or dividing measured numbers, you go with the fewest number of significant figures. When adding and subtracting measured numbers, you go with the fewest number of decimal places, or if there are no decimal places, you go with the highest non-zero place value. Hopefully that wasn't very challenging, because now we're going to make it more challenging. We're going to be doing both multiplication, division, addition, and subtraction in the same calculation, combined calculation. This can be a challenge. Please ensure you use BEDMAS. Always use BEDMAS. Remember, these are groupings, these are groupings. When moving from left to right, you do whatever one comes first. Just because D comes in the word BEDMAS before M doesn't mean you have to do division before multiplication. You do whatever comes first when reading the problem from left to right. So let's not worry about significant digits right now. Let's just do the calculation, get our final answer. Remember, we're not rounding off until the final answer. So let's just forget about rounding off and do the calculation. Example 9, we might make sure we follow BEDMAS. We are doing brackets first. 2.13 times, in this case, we're adding up 1.2 and 23. So we're multiplying this by 24.2. We then multiply those together and we get 51.546. But we have to round that off. So what we have to do is kind of keep track as we go. It can be a challenge. So if we look here, this has 1 decimal place. This is to the nearest 10th. And this has no decimal places. This goes to the nearest 1. So if I was to round this value off here, where would I round it off to? I'd round it off to the nearest 1. So what I like to do is draw a little line underneath all the significant digits. Now remember, don't round this off right now as 24. In doing the calculation, we have to use 24.2. But temporarily, we're just going to underline the 2 and the 4. Now we're doing multiplication. With multiplication, we go with the fewest number of significant figures. So this one has 3 significant figures. Now the 2 and the 4 are both significant, so this one has 2 significant figures. As a result, you go with the fewest number of significant figures. We're rounding off to 2 significant figures. This rounds off to 52. So you can see this can be a challenge when we're mixing and matching addition, subtraction, and multiplication or division, because there are 2 separate rules for rounding. Addition, subtraction, you go with the fewest number of decimal places. With multiplication or division, you go with the fewest number of significant figures. Let's try the next one. Again, we must follow BEDMAS, so we're going to work on these first. 1.54 minus 3.2 divided by 1.5. We get 2.1333 repeating. Just going to save time by writing a bar over top of the 3. Then we do the subtraction here. We get negative 0.5933333 repeating. Again, I'm going to use the bar notation. But this is not the final answer yet. We have to round it off. We will state that all these numbers came from measurements. So let's examine. First of all, we're dividing. We go with the fewest number of significant figures. 2 significant figures, 2 significant figures. So if I was to round this off, I'd round this off to 2 significant figures. Now that I'm doing subtraction, a different rule applies. I go with decimal places. This has 2 decimal places, and if I was to round this off here, this would have 1 decimal place. So in the end, I'm going to round this off to 1 decimal place, giving me negative 0.6. Final answer. There's 2 more here. I'd like you to pause the video and give these a try on your own. Remember to always use BEDMAS, and remember fewest number of significant figures for multiplication and division, fewest number of decimal places for addition subtraction. So here we're using BEDMAS. When reading the problem from left to right, we start with multiplication. This gives me 10.008 plus 9.33 divided by 2.0. Now that I've done that, now I move on to division. 10.008 plus, I'm dividing 9.33 divided by 2, 4.665. Now that I've done that, I can now do addition. This gives me 14.673. Now let's round this number off. Notice I did not round off any values. This is now the final answer right here, and now I'm going to round off only at the final answer. So let's examine multiplication. We go with significant figures. This is 3 significant figures. This is 2 significant figures. So if I was to round off this 10, we round it off to 2 significant figures. Over here, I have 3 significant figures, and I have 2 significant figures, again because I'm dividing. So if I was to round off this value down here, it would be rounded off to 4.7. But I'm not rounding that off just yet. Now I'm adding them. Here, this is 1 decimal place. Here, this is no decimal places, or to the nearest ones column. So I'm rounding to the nearest ones. I'm rounding off at the 4. This rounds off as 15. Let's try the next one now. Let's make sure we follow BEDMAS. So we do these brackets first. You could do this addition with the other one, but I'm just going to use an extra step right here. Now we combine those together. Now we're multiplying. Multiply those values together. 2827,422. Now we're going to round off to the correct number of significant digits. Let's look at our first operation here. We had 1 decimal place, 1 decimal place. So rounding this off to 1 decimal place. So all those figures are significant. Let's look at our next operation. Here we have 1 decimal place. Here we have 2 decimal places. So 1 decimal place is lower. So we'd round this off to 1 decimal place. So that gives us 4 numbers there. And we have 3 numbers there. Now we're multiplying. This has 3 significant figures. This has 4 significant figures. So we're rounding to 3 significant figures. This gives me 2830. Final answer. These combined calculations can be a challenge. Therefore, there's a large worksheet I have for you at the end of this lecture to practice. I want to point something out here. This is a common mistake students have. They had a problem like this. And they see subtraction, they see division, and they see addition. And they, for some reason, decide to say, well, I'm going to stick brackets around here and here and here and here and do my subtraction first, then my addition, and then at the end, I'm going to divide it. That's wrong. Also, I see this quite a bit. Students see this value here, and they see this value, and they say, well, this is 32.1 minus 4.0, and then they write divided by 92.1 plus 852. No, that is incorrect. That is what that is equal to. If there's no brackets here, what we have to do first, we have to do the division first. So you could rewrite this as 32.1 minus 4.0 divide by 92.1, add to that 8.52. Notice these two things, they're not equal. So as a reminder, if you don't see brackets, don't add them in. This is a common theme that students do. They stick brackets in. If they don't exist, don't add them in. There's a large number of practice problems here. 1, 2, 3, 4, and even some word problems. I believe students need a lot of practice on this, so this is your opportunity. The good news is, if you keep scrolling down, there's all the answers. I've checked them myself. Hopefully I didn't make any mistakes. I'm pretty sure those are all correct. So what I want you to do here is I want you to do these operations, assume all the numbers are measured numbers, they're approximate, and round off to the correct number of significant digits. Remember, when we're multiplying or dividing, we go with the fewest number of significant figures. When we're adding or subtracting, we go with the fewest number of decimal places. And with combined operations, you have to track it throughout. But a common theme across the board is do not round off until your final answer. If there's only one thing you take away from this lecture, it is do not round off until your final answer. Keep all those digits in your calculator, and only at the end, round that last number off. Don't round off throughout the problem. That's all for today's lecture. Until next time.